All right, so picking up where we left off with the previous video so now here we are. In some cases, a successful strategy involved thinking hard about P of K and determining how to modify it to arrive at P of K plus 1. This is a strategy used in the previous proof, and we're also going to use it in Theorem 13. So here we go. Let's go full screen and clicky. All right, here we go. So just kind of it's, like one thing to think about here is sometimes in preparation, it's always kind of a good idea to kind of like work through and kind of make sure things are working, kind of get a visualization. Obviously, this is the P of 1 phase right here. So right there. And we'll see that on the next slide. So in P of 1, so that's our basis step, we can say that we know that 1 plus 2 of 1, 2 to the 1, is equal to 2 to the 1 plus 1 minus 1, which gives us 3 on the left, 3 on the right. So that statement is definitely true. The Baseman statement is good to go. All right. Inductive phase. So in the inductive phase, this would be our P of K. So what we've said right here is this step right here is our P of K. So what we're going to do is now we're going to show P of K plus 1. So to do that, you can see that I added 2 raised to the K plus 1 to both sides. And then I was just able to rearrange through, I want to say the associative property, and I'm going to say yes. So through right there, that was the associative property. I was able to rearrange this and kind of just move things around. So I was adding different things at different times, right? At that point comes in our properties of exponents. And so with our properties of exponents, we have this idea that we are essentially, if I look at the 2 to the K plus 1 plus 2 to the K plus 1, if we simplify that and think about that for a second, essentially what we're saying is, it's like if we had a 3 plus a 3, then we could say that's 2 times 3, right? Because there's 2 of them. So that's what we're saying here, is we're saying, okay, well, I have 2 K plus 1s. I have this K plus 1, 2 to the K plus 1. I have this 2K to the plus 1. So I can rewrite that as that statement right there. All right. Now the cool thing about this is that at that point, we can take that 2 times 2 to the K plus 1, and we can move this through and realize that what we really have here is 2 to the first times 2 to the K plus 1. So now, this is kind of getting crazy, and we're really getting into our exponents here. This 2 to the first power is allowing us to kind of think about this as being, and I'm going to hit pause to make sure I get this right. All right, I just had to write it out to myself real quickly so I didn't like do something wrong. So this is where the part, like if you're like rusty with your exponent rules, so that's 2 to the first still in the front, times 2 to the K times 2 to the first. So what I did right there is I took this part and broke it down. Now when I put it back together, what happens is I get the 2 to the K, but then I have a 2 to the first here and a 2 to the first here. So then I get times 2 to the second. And then from there, I get 2 to the K plus 2. So properties of exponents back from your algebra class, pre-calc class, see if those are still fresh, and that'll kind of help you get through that. So that's how I got to this phase right here. Now, why did that benefit me is because now I can break it down and I can then say, okay, well, if I think about this, I can factor out that 1 right there on the end and show that I have K plus 1 minus 1. So this statement right here is showing this plus 1 statement and the K plus 1 statement. And so what I want to challenge you here is that by going through manipulating that, get to that spot, this is where it's like they talk about how it's tricky. It's like, how do I really know I proved that? So once again, if you wanted to, we can take an arbitrary n. So we can take n equals 3. And we can come across here, and I'm not going to do this time. You can do it yourself. So then I get 1 plus 2 to the first plus 2 to the second plus 2 to the third. See what that equals. And then I can come down here and I can say, okay, well, what would this be? Well, that would be 2 to the 3 plus 1 minus 1. So just real quickly, that would be 4, 5. So 2 to the 5th would be 32. So 32 take away 1 would be 31. On the other side, that would be 8, 4, 2, and 1. So let's see. I didn't quite get there. So where did we go wrong? Let's hit pause and see. I know where it went wrong. I didn't do the k plus 1. So let's grab the eraser real quickly. So I got that. That's this piece, right? So I got to that spot, the 2 to the 3rd power, but I forgot to do plus 2 to the 3 plus 1. So that's 2 to the 4th. 2 to the 4th is going to be equal to 16. So now I've got 12, 14, 15, and 15 plus 16 is equal to 31 also. So there I just chose an arbitrary number to prove, and that might be something you can do to make sure that what you have is actually showing. This is the part right here. This piece right here is the part where they're talking about on this previous slide that just really makes it really tricky, right? Like this is the piece where you're just like, this statement where they're saying like, that certainly illustrates how to the basis step. That's not the right statement. Sorry about this. It's this one right here. In some cases, a successful strategy is involved thinking hard. The strategy is used in previous proof, and it's not always easy to do. So just kind of keeping that in mind. All right. So that takes care of theorem 13 or 16, excuse me. All right. Some final thoughts. Let's clear our screen real quick. In 15 and 16, we found the connection between the inductive hypothesis, so P of k and P of k plus 1. By thinking hard about P of k and determining how to modify it to arrive at P of k plus 1, that helped us solve. An alternative strategy is to look hard at P of k plus 1 and try to modify part of it to get back to or to connect back to P of k. All right, and so to do this, take a look at 17 and 18 on pages 120 and 121. Look at those examples in the book. So remember, that's just referencing is that I'm not going to go through in these videos and do each theorem. So making sure you're looking at the theorem in the book, using as examples, and using those examples of how they did it to be able to apply it to your homework problems. All right, that's it. That's the third video. Hope that helps. Good luck with section 3.3.